Okay, hypothesis testing. In lesson 8, we started on this topic. Of course, you know the definition of hypothesis. It is the statement about value of a parameter. Now, as you know, two types of hypothesis, H naught, HA. Null hypothesis H naught is the one you want to reject, gathering sample information. HA is the one you want to prove, gathering sample information. So many times we call it research hypothesis, alternative HA. Okay. Now, for parameter pi, alternative can be three types. In general, for any parameter, say if it is mu, it will be mu greater than mu naught, pi less than pi naught, pi naught equals to pi naught. This is called right-tailed test. This is called left-tailed test. This is called two-tailed test. But for every one of them, null hypothesis, for simplicity, we will take it to be pi equals to pi naught. Now, for example, when it is the right-tailed test, since it is greater than sign, the null hypothesis, the equality sign, the sense is the opposite of greater than, less than or equal to. But you are, for simplicity, you will be using equality sign. In a given problem, pi naught will be known. So you start with this, and then once you have your alternative hypothesis, just replace the equality sign by this greater than sign by the equality sign. Now, let's talk about that second part, decisions and errors. At the end, doing the testing, our decision would be either reject H naught or do not reject H naught. These are the vocabulary we use. Reject H naught means, of course, we believe in alternative, and do not reject H naught means we cannot believe in alternative. Now, errors also have two types, type 1 error and type 2 error. Now, read your notes about this. Type 1 error is when you reject null hypothesis when H naught is true. But alpha would be very important quantity for you. It's the probability of type 1 error. And that's called the significance level or level of significance. There is, of course, another thing called beta, which is probability of type 2 error. You will see those things in coming lessons. But most of the time, we do a testing with a fixed alpha. Now, very important thing, in some situations, when you formulate null and alternative H naught and HA, you have to keep in mind probability of type 1 error. Or rather, just the type 1 error is more serious. Okay, now about the actual testing now. p-value approach and rejection region approach. There are two approaches of testing. In lesson 8, we have p-value approach for the parameter pi. Okay, but note that later when you study also rejection region approach, p-value and RR, rejection region approach, gives you same conclusion. Okay, now let's see p-value approach for the parameter pi. These are the steps you have to follow. Number 1, formulate H0 and HA. Number 2, the test statistic you might have read under certain assumptions, assumption being n times pi naught greater than or equals to pi, n times 1 minus pi naught greater than or equals to 5. In that case, the distribution is a normal distribution, so it's a z, and the value is pi hat minus pi naught divided by square root of pi naught 1 minus pi naught over n. The third step would be compute p-value. Fourth step, this is what one you have to remember. For a given alpha, the universal rule of rejection is the following. If p-value is less than alpha, you reject H0. If p-value, of course, then the other case, p-value is greater than alpha, you do not reject H0. Fifth step, whatever you do, reject H0 or do not reject H0, write your conclusion in words. Now let me give you an example. Suppose it is thought that more than, this is the contention, belief, more than 7% of all faults are due to faults in, say, transmission lines are due to lightning. Now, this is the contention. Now, another thing, the sample, what was seen, the random sample of 200 faults yield that 151 of them, of these 200, due to lightning. Problem is, test the contention at 1% significance level, or it can be given as alpha is 0.01. Now, first step, what you do is you form H0 and HA. Now recall that contention is more than 7% are due to lightning. So it's a proportion. 7% is related to proportion of 0.07. More than means that 0.07, and the null hypothesis will be pi equals to 0.07. Although it is carrying the sense, this equality sign is carrying the sense of, less than or equal to, opposite of greater than. So that is the first thing. Now, for the test statistic, whether it is normal or z, you need to test this. N times pi naught, n here is 200, pi naught is this value, 0.07, which is what, 140? No, it is 200 times, it's not 0.07, it's 0.7. So you have to be careful about the 70% means 0.7, not 0.07. So it is 0.7, 140. That's more than 5. N times 1 minus pi naught. Of course, it will be 200 minus 140, which is 60, which is also greater than or equals to 5. And this tells us that the test statistic, it should be z, normal distribution. But it is this expression, pi hat minus pi naught square root pi naught times 1 minus pi naught over n. Next, pi hat. Pi hat is what? What proportion? 200, out of that 151 due to lightning. So it is 0.755. So the test statistic value would be z equals to pi hat 0.755 minus pi naught, which is 0.7, divided by square root of pi naught, 1 minus pi naught divided by 200. When you calculate, you can see it will give you 1.70. Now, why did we have the second decimal place accuracy? Because your normal distribution table goes with the second decimal place. Now, the p-value. P-value is the probability, and you know from your lesson notes that your alternative was with the greater than sign, pi greater than 0.7. Since it is greater than sign, here it will be greater than sign. Test statistic was z equals to 1.70, so it will be that. So recall, your test statistic was z equals to 1.70. So replace the equality sign by the greater than sign to get this. Now for this, you look at the table and you know it is 1 minus probability z less than 1.70. So 1 minus 0.9554, which is 0.0446. Now what you do with the p-value, remember your alpha is 1%, 0.01. P-value you just now calculated 0.0446. So when you compare these two, you know your p-value is greater than alpha, and that tells you that you do not reject null hypothesis at alpha equals to 0.01. Solution is at 1% significance level, the contention that more than 70% faults caused by the lightning, so that contention is not valid because you are unable to reject null hypothesis. Since you are unable to reject the null hypothesis, therefore you believe the null hypothesis, therefore you do not believe the alternative hypothesis, and your contention is your HA, right? So you cannot reject null hypothesis. That means you believe that kind of H naught is true, and therefore HA is not true. Contention is not valid. So you have to see these steps, logical steps, one by one to come to this type of conclusion. Now, note here, if your alpha was not 0.01, then what happens? In that case, p-value remains the same. You don't change it. But this time it is more than It is less than alpha. It is less than alpha. And therefore, you reject this time at alpha 0.05. See, we did not reject at 1%, but we reject at 5%. Same p-value though. P-value does not change. So, you can write at 5% significance level, we believe contention is valid, because contention is in your alternative hypothesis, and since you are rejecting null hypothesis, that means alternative hypothesis is valid, contention is valid. So you see that same p-value will be okay. We'll be doing the purpose. You don't have to change the p-value. Same p-value for all different alpha.